Hey everyone, and welcome to this recording and episode of Co-Creating with AI. I'm Martin, and with me, as always, is Rasmus. How are you today, Rasmus?
I'm good. I woke up quite energized and excited to chat with you today. And today I think we're going to chat about hosting your own AI models and the benefits of it versus calling APIs. I mean, of course, there are benefits of both, but I think for most and for me, I'm much more knowledgeable within what you can do with the kind of services out there that you can call via API, and of course the consumer services that you just log into and use yourself. So yeah, I mean, I'd love to dive into that. I know you've been experimenting a bit with that lately, so maybe I don't know, maybe just start there, like what you've been doing and what you've been discovering, and then we can take it from there.
Yeah, and first, just to frame it with what we're actually talking about, is that AI models are run on GPUs, and often you need pretty heavy uh, power, like hardware power, in order to run inference on models or train them. And um, what I've done up until now for a long time is to basically almost use other people's APIs. Other people are hosting their AI models and offering them as a service through an API, and you pay for it often by for you pay for every call, or even like in the case of OpenAI, you pay for the number of tokens that you send in and you get back. So it's a very like it's the model is very fixed on the value you get, which is awesome because then it's very cheap. If you don't get any value, it doesn't cost anything, and then as your value goes up, the cost goes up linearly. So that the API model is awesome. I'm very familiar with it, and still I'm having so much fun exploring what happens when I host my own models on hardware that I control. And in my case, I rent it from the cloud, since buying expensive GPUs is actually not worthwhile when you can just rent it by the hour.
Cool. Okay, so I mean, so that's interesting. So you're 'cause I want to dive into the benefits of it, but just on a high level, right?
Mhm.
So do you think, like, I mean, because obviously, just to sort of make a punch for the APIs, right? The main benefit there is, getting something that works, well for a specific use case
Yeah,
quickly with, very little development time, right? And
yeah,
without having to care about a lot of the things. I mean, I guess the DevOps of the model, like where it runs,
exactly. Yeah.
etc. And now you've taken like a little bit, like one small step further down the stack, I guess,
Mm.
with renting your own GPU, so to say. I mean, it's not only
Yeah,
yours, but like renting
yeah.
GPUs and deciding a model to run on it for a use
Mm.
case you want to. So can you just dive into like what that enables? Maybe like what have you seen so far? Because you were quite excited, like in the pre-chat, about the kind of the flexibility it gave you. So can you just like can you
Yeah.
exemplify that some way?
Yes, so I'm working on a conversational model, and an AI that I can talk to, and in this case, what I can do is I and what I need to do is that I need to really tweak the small details of how that solution will be set up. And it also turns out that when I um, sort of cobble together a service like that from existing commercial APIs, the end result becomes very expensive. I need to like glue together, I think maybe 6 or 7 different AI models with different purpose, like understanding spoken conversation, reasoning about the results, and maybe fetching data from somewhere, and then inferencing something to say back, and then speaking, like turning text into audio, voice. And so all of that is like in that value chain, there's probably 6 or 7 APIs that can all be pretty expensive to run continuously, which is like in a conversation, you want to like have a meeting with an AI or have an AI listening to a meeting, it can be an hour long or more. And if you want to do that often, the cost can actually become prohibitive. So what I can do with renting my own GPU in the cloud, that I can put maybe half or most of those models on the same hardware. So I can create my own stack on a single computer, or a set of computers, and I can then rent that box by the hour and pay for all of it by the hour, and just use that GPU hour that I have the flexibility to like paying once and then using that compute for my purposes the way I choose to.
But okay, that's interesting. So in this case, did you first cobble together the APIs? Is that how
Yes,
you did it?
yes,
So you
yeah,
first cobbled together a bunch of APIs, and you started to get to like, okay, I'm starting to understand how this should work,
yeah,
and this could work. And I guess, I
yeah.
mean, it's not a finished product, right? But
Mm.
still. And then you're discovering that, oh, this will be cost prohibitive. This won't
And
work. Is that like?
exactly,
And then you started looking at like,
yeah.
okay, how do I do that? Uh, and then you start finding open source models that are like I guess equivalent or like correspond to do the same
Mm.
thing as the ones you were previously taking via API. Is that like
Yeah,
how you've been approaching it?
yeah, exactly. And it was actually not the cost that was a driver for me to start exploring hosting my own models. It was the flexibility, because you run into limitations with the API where you can't you actually can't influence how they receive data or send data to the granularity that I need. And there's
Can
also
you give an example, like just
yeah
like anything
so
specific there?
yeah so I want to understand what happens in a conversation, like in such a minute detail that like there's no one else providing the level of detail that I feel that I want to explore. So I want to give
Mm.
the AI like a millisecond by millisecond map of what happens in the conversation, so it can partake with the same amount of flow that a human can do. And there's no API that does that. There's like it's very like sending data back and forth. Here's audio. Give me text back. Oh, now I have text.
Mm.
How should I reason about this text? And and then there's some streaming APIs, and that live like can take in data in real time and give back data in real time, which is super valuable when you're building a flowy conversation. But those then are providing much less information, and because they are not as refined, that like their unique selling point is the real time. There's no like best of both worlds in the API world, where you can get both the most features with the most details delivered, but also like the fastest in real time. In the API world, the companies are doing trade-offs where like people needing real time, they might not need that much detail, or it takes time for them to develop.
Right. So it's basically you, like, instead of someone else making the trade-offs, you make the trade-offs because there are always
Yes.
trade-offs to be made, right? And then you can
Yeah.
make the trade-offs you need. Okay. That makes
Mm.
sense to me. But I mean, you're not training your own models yet, right? You have
No,
you're
not yet.
taking existing open source models. And
Yeah.
because like one of the main, I guess, narratives out there, and that at least I've sort of heard and seen, data on, evals on, like evaluations on, is that the open source models generally are not up to scratch with, say, the state of the art models, right? So there's still no
Mm.
open source equivalent to GPT-4 as far as I've seen,
Mm.
and there's no, as far as I've heard, open source equivalent to, say, Whisper, text to audio, audio to text. So what, like, have you like looked into that yet? Like, have you, when you start experimenting with these open source models, which I guess they all are the ones you're self-hosting, right?
Yes. Yeah.
And now you're taking these, I guess, the best in class kind of API provided models and that stack, and now you're going to move it to your own stack, so to say, on your own GPU.
Mm.
Like, what's been
Mm.
your experience of that? Like, is that a false narrative, or is it like a challenge?
So there is a challenge. Like I'm not, I'm no, like I'm not a full stack developer, but so like the past few weeks I've been have like have circled a lot around learning how Docker works and how to deploy AI models to the cloud, and going through a lot of frustration around that as well. And those hurdles are solved with the API. Like with the APIs providing similar but less flexible functionality, I was able to be up and running like in a minute with every API. It's so quick to explore with when someone else has done all the work to deploy a model to the cloud, to explore the capacity of that model and so on. But regarding the capability of open source versus closed source, actually, um, with the base, like the foundation reasoning engine, GPT-4 is still the best LLM out there. But with the functions that I use now in the open source, with the functionality that I put together, it's actually um, all of the, and almost all, I don't know about if it's all of them, but many of the speech to text services are based on Whisper, which was developed and released by OpenAI, and which is available open source. So
Right,
the state of the art performance is open sourced, and
right,
whatever they put on top as their own magic sauce is rarely something that I need. What I need is like the the speech to text functionality with um, like at low cost with high precision, and that I can get from the open source.
right. Okay, so this is interesting as well. So I mean, that makes sense. So part of the open source stack is more state of the art, right? And
Mm.
some parts are still held, closed source by OpenAI, Anthropic,
Yeah.
Google, etc. Right? That makes a lot of sense, and you can also see, I guess that will be like an informing factor in how you, in what kind of setup you have, right? So, for example, at
Mm.
Multiply, as you know, right, we for our customers who are like primarily marketing agencies and in-house marketing teams, then relevance and quality of the text generated is
Mm.
like extremely important. So that means we can do a lot of stuff before we generate the final text. If there's a lot of data, we can compress it. You upload 10 files, or you link 10 web pages or whatever that you want as input for the content you're producing, and then we can compress it. But the final thing we still need, I mean, we'll see, but our judgment so far has been to go with GPT-4 in the
Mm.
final step, because the quality uh, is so important, both of the, like, just the vocabulary used, right, the style. It's very important, for whether it's a marketing agency or an in-house marketing team, to communicate in the brand voice and the exact style and the same format as previous content, etc. But also to actually have high relevance, to use all that input data to, in with the reasoning engine, which is
Yeah.
superior, to like actually produce very, very highly relevant and engaging content. So that's
Mm.
interesting, and there, like, the which is going to segment to another part of this, but it's interesting there with audio and text to audio, that it's
Mm.
further along there, like it's closer to state of the art.
Yeah.
um that's, I mean, that makes a lot of sense.
And there, I think one keyword that you also think about is that you say that in the final step, Multiply needs to use GPT-4, and that's true for what I'm building on my side as well. That I'm for reasoning, I don't want to settle for anything less than state of the art, for like to use the best intelligence available, and right now that's GPT-4. But both in Multiply's case and with Kindship, what we do as an optimization, both for cost and speed, is to use a less capable model as pre-steps, like to put together the context for the expensive GPT-4
Yeah.
AI. and that can, I think there, it's there's a very good, there are very good benefits of in exploring where exactly are the best performance cost benefit ratio, and in my case, like in a conversation, I will model the AI as a human is sort of modeled in our heads. We have famously system 1 and 2 responsible for
Right.
thinking fast and slow, and in my case, like the AI, the portion of the AI that will need to think fast could be like a Llama 2 chat model, because I can host it on the same machine as the rest of the functionality. It doesn't have to, the data doesn't have to traverse like over the web, um, like two more jumps back and forth before for that to happen. So it's also very performant to have everything on the same machine.
This is perfect segment to exactly what I wanted to go to, which is reliability and latency. So those have been like two of the main kind of factors where, like, you know, in Multiply we've been, we're of course experimenting with different things, but making a serious push to take part of the kind of API layer. I mean, in-house, so to say,
Mm,
not via API.
mm,
And and there's two parts there, right? So the reliability, because the kind of APIs can have downtime that is out of your own control, or they
yeah.
can be kind of overwhelmed with traffic. There's like some famous memes and jokes around it, even though we're
Mm,
able to manage that well, I'd say, in our case. But then there's the latency part. Like, what's your experience with latency? Like, is the so to be very clear, right? When you send like a prompt to any AI model, right?
mm,
Then there's of course the time it takes for that information to go to the other end. Then it's the
mm,
time for that information to be processed by the LLM, by the model,
yeah.
and then it's time it's sent to, like, time it takes to send back. Like, so do you like, and then that of course turns out to the total time for
Mm,
like doing the task you ask it to. Like, what's your experience so far with like latency? Because I could argue theoretically that it
mm,
shouldn't make a difference, because you're still like running it through the same model, and the transport time, so to say, over the web is just milliseconds. It doesn't matter.
yeah.
But I could
Yeah.
also argue that it is. So, like, what's your experience so far with latency?
Well, so far latency hasn't been much of an issue at all, and with AI models, they are doing so much computation that, just as you say, like the latency is just a few extra milliseconds on something that can very well take hundreds of milliseconds. So the latency transporting that doesn't amount to much actually, but it is when you're doing more complex tasks, when you're going to the data runs to a pipeline of many models, that maybe then it will start to, if
Right.
each of those jumps between models are in the pipeline, have that latency of a few extra milliseconds, that can start to amount to something. And but in general, it's the overall computation that is the hurdle that I need to get over in order to achieve a real time system. And the latency of transporting it is less of an issue. And there's so like amazing technologies with WebSockets and so on that can have almost instantaneous data transfer to anywhere in the world.
Okay, nice. Yeah, I mean that's good to know. I mean, because my sense is that on the topic of like having a pipeline of, I mean, models or steps in
Mm,
terms of getting your result, like a big part of it, it seems to me, is trying to reduce the amount of data that goes to the final
yeah,
slow and smart model.
yeah,
So that we're playing around with a bit when we're like compressing information. If there's
mm,
like a lot of information, then we can either compress it so it just fits within like GPT-4 context window, or we can compress it maximally to get
yeah,
like a smaller prompt as we think can work, to like, so less data, more dense
mm,
information, to the GPT-4 model, which both reduces cost, because that one is much more expensive per token than the models we use earlier in the pipeline, but
mm,
also speed, because it's slower. So, uh, I don't know. I mean, I guess that's part of what you're doing, right? It's like if you, especially when you take like conversation per millisecond, right? Does that sort of rhyme with your thoughts around
Yeah,
it?
yeah, definitely. And uh, also the normally you have a lot of possibilities in creating a user experience where latency doesn't matter, where you can cover up the latency with some funny animations to look at, or some progress bar that the user will think, oh,
Mm.
that's a very fast progress bar. I don't need to. And it's just that in my case, when I'm trying to have or create a very flowy, like a state of the art flowy conversation with an AI, a progress bar is not going to cut it. And like a
Yeah.
fancy animation to cover up a delay will actually not be it will never be as good as having an immediate response. So that's why I I'm not, it's not my focus yet, but it's like shaving every millisecond off the response time is going to be crucial for me in the end.
Right. Interesting. And is there any way to like dive into? So we talked about like we touched on trade-offs, right?
Mm.
But are there any like more details you can give there in your case, or and in other cases you know about, like in terms of um, the I mean, if I mean, I guess if listeners are thinking about something specifically they want to solve, there are a lot of options. There are everywhere
Yeah.
from going directly to a no code tool such as ours, right, with multiply and solving it, and then you can build something with an API, build it yourself, or
Mm.
you can go and take it steps further, right, and self-host, etc., like what you're
Mm.
exploring now. Like, what do you have any like any general learnings or any examples that you think are relevant?
I think that the overall process is that we talked about in the beginning of that episode is very good um, to employ, that you start with using APIs, and then when you start realizing what models are you actually useful for your use case, then you start to look into self-hosting them if you run into the need for that,
Yeah,
because the speed of innovation is also crucial for any business or whatever you want to do, like to get to actually trying what you want to achieve, trying it out in the real world is really like crucial. So and using existing production ready APIs for that is just unbeatable, because there's always a lot of hassle hosting your own things. There's no matter, like I'm not an experienced like full stack developer, but it requires a really experienced developer to never run into
yeah,
any problems. And like I don't know that if that person even exists, because everybody is challenging themselves to push themselves to the next level where the challenges are. And so but that workflow works great, like starting with APIs and then seeing, do we really need to go to a self-hosted solution, because maybe the API is just as good. But also the like keeping an eye on exactly like where what is my usage. Will I call this rarely? And then maybe it's better to use an API. Will I call this all the time? Maybe it's that better to self-host, even though it's a simple solution, and because I want it to have running all the time. And
mm,
then there is also the sort of the middle ground, where there are also like serverless GPUs now to rent from RunPod and other providers, where you can deploy your own Docker image with your own AI models, but they are not alive until you actually call them, and then they are live for 5 seconds before they go to sleep. So you only pay for the seconds that you use, instead of paying by the hour.
interesting. I mean, I think like from what I see, both with friends within the space and with our customers, is that like usually like the pattern I'm seeing is that like the vast majority of people are like who are starting to look at using AI, right? and like a lot more of them than you might think. Like it's much broader, like in terms of adoption than what I initially thought. Is that first people start with the super simple version, right? Just use ChatGPT or Midjourney for a simple thing, right? And then
Mm.
when they try to discover, like they discover a workflow, then they try it via some kind of no code tool, make.com, etc. Something where you can like set up a or Zapier, like set up an if this then that flow of things happening,
Yeah.
or in our case, actually looking at in an organization, like trying to approach it systematically, like which workflows do we have, and like build them all in one place so they can be shared within the team, right, and used by everyone. uh, but then it's interesting because I think like the way this is happening, right, it's like in all of these kind of generations of software, it's like either there is an application and the person and then someone you use that to get it done, or there isn't, and then either you have someone building it as a product to offer to you, or you build it
Mm.
yourself if it's need for like to have it internally, proprietary within your company, even though it's not your product, it's part of your process, right? uh, and there it seems like, I mean, the kind of, I agree with you, the way to go about it, if you can't solve what you want to do with kind of the ready-made consumer tools or the no code kind of tools, then you start with API. And when you run into limits because you have something specific you want to get done,
Yeah.
then, and if you run into the limits, whether they are in terms of latency, maybe not the primary one, or cost, or because of the flexibility you need, then you go down the stack. So it's interesting. It's I don't know, I just think it's very impressive that already
Yeah.
like a year into this, you have that kind of, I'm not sure what to call it, but those levels
It's
of the stack that offer
exactly.
these different versions. It's
Mm.
like the speed is quite incredible.
Yeah, it is, and it really also speaks to the power of human collaboration, that we as humanity create these AI workflows and these solutions, and each of us make our own sort of puzzle of how we fit the pieces together, and we can do it on different levels. Like some do it just in a service, and some do it in no code, and some do it very close to the bare metal with coding their own models and training their own models from scratch. And but the sharing that is going on, no matter if it's through an API or through open source, putting a project on GitHub and putting the research paper out and publishing it, what you've achieved, like that the scale of collaboration that humanity is achieving is completely astounding and then marvelous.
Yeah, and I mean, yeah, I agree. I guess just one last thing we didn't touch upon, maybe it's not necessary, but I think like one major driver for what you're doing and been exploring now is just keeping your data in-house, right?
Yes.
Um, Even though like, I mean, for example, for our like customers, some of them have been using ChatGPT a lot prior to using Multiply, and then they're like, "Oh, we can't do this in ChatGPT because they will use that data for training their models." But actually,
Mm.
like in the terms of service we have with OpenAI, they can't use our data to train their models,
Mm.
and they have to delete it, either upon request or latest after 30 days. Um, but there's still that drive for like being sure that your data doesn't leave the system and doesn't leak,
Yeah.
for a lot of different cases. And I think that's going to be a major driver for, say, RunPod, and like for the demand for self-hosting, uh, you
Mm.
know, models in different ways. Um, at
and
least
and
from what I've
that's
seen.
yeah, and that's also like perhaps one final benefit of the self-hosted model, that you can, if you build a commercial solution, if you self-host everything in the end after you prototype with a lot of APIs, once you have achieved full self-hosting, you can also offer that box inside companies, inside the walls of a company, or within the home of an individual, and that they can also feel that we have full ownership of both the software and the data, and that benefit is impossible with APIs, and um, And APIs as a collaboration model, so to speak, is has also a lot of benefits, but privacy and integrity and ownership of data is really a benefit of self-hosting.
That's actually really interesting. That, like, I don't know, this is probably a topic for another episode, but just the final kind of thought that hit me from that is that this drive might be, almost a return to like installing software on your own computer, so to say.
Mm. Yeah.
Because, say, if I want to install my, AI assistant, and I want to make sure that, I can trust it and my data doesn't go anywhere, and also it's quick and everything, then that's basically going to be like a package that I install on my computer, and then maybe I trust that, Apple has strong encryption, and, my data on my hard drive won't leave there,
Mm.
etc. Which is, very similar to how the open source community offers, they offers the self-hosting, right? Whereas
Yeah.
we've been used to software that is run in the cloud for a long time. So it might be like that. This is like, I don't know, that this
Closing the circle.
yeah, sort of, right?
Yeah. Yeah.
Yeah.
Yeah. Might
Well,
be.
let's see. Yeah, I mean, topic for another episode maybe. But thanks a lot, Martin.
Mhm.
It's been fun.
Yeah. Thank you too, and thank you to our listener being with us all the way to the end of the episode. This has been co-creating with AI, and as always, get in touch if you want to have questions or input on future episodes.